But now think about an estuary. There's one there on the west of Tampa Bay, where a lot of these things are found. But of course, estuaries are formed where rivers are getting down into really low areas and they fan out, to multiple little things, kind of a semi-delta thing. And the streams are about that deep. And then they flow into brackish water and, ocean water that's about that deep. And let me ask the question again. Okay. Are you likely to find elephants and whales living side by side in an estuary? And the answer is no. Okay. We know way too much about estuaries. That would explain how you might find a few land and sea creatures next to one another, clams and snails and so on, but not whales and elephants. And, it's just not going to happen. Of course, they're not going to be buried and preserved. Estuary environments are rich biologically. What does that mean? It means they got a lot of hungry critters in them. Some elephant dies, they don't build a fence around it and say, keep out, this one's fossilizing for future discovery. Crabs, everything else pounce on it. Some of them pounce on it high tide, low tide, the thing. Same thing if a whale got beached. It's not going to fossilize in that kind of environment. And so that's amazing how sometimes evolutionists will toss out some little, oh, sure, yeah, estuary. No. Be ready with a follow-up question. And so even that, now the state geologists don't say that. That would be, just a person, an amateur that would say that. The state geologists are really, wondering about this stuff. And so they call Florida fossil hash. And, that most of it's what we call tertiary, the upper part of the geologic column. And in the Paris Basin, probably in the 1800s, probably 1800s, they broke up the tertiary based on layers around Paris, France, into Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene. In recent, the top two being Quaternary. And the state geologists in Florida say, they use those names in books, but you can't really tell. It says the names don't mean anything around here. They just don't apply. You get all of these things all stirred and mixed together. And so that's kind of interesting. All of these things stirred and mixed together. How did that happen? Okay, and so that's the next thing. Okay, and many of you know this book. This is by Michael Lord, one of the first children's books. So this is really an awesome book, extremely well illustrated. Life in the Great Ice Age, great introduction to archaeology for a young person. Some of these books are just going to make young people, I want to go into this, I want to do this, this is how I can serve the Lord with my life, etc. And so this is really kind of spectacular. Of course, Michael Lord also does the high-level research. And so he's got a new book, relatively new book out, Frozen in Time, about the mammoths in Siberia and so on, a really interesting concept of how those formed. And he's got a more recent one than that, and I can't think of the title right now. Anybody know? I think he's got one that just came out, but still Ice Age kind of stuff. And he's a meteorologist with specialty in that area and a great speaker. I think you've had him here once, and enough has happened since you've had him here. You might want to have him again. Well, most of the fossils, when we talk about fossils, we're talking about what you see here in Colorado. Layers of rock deposited during the year of Noah's flood. As the waters rose over a 5-month period in the early part of the flood, they buried the heavy-shelled bottom-dwelling sea creatures first, and then as that basin filled up, it buried some near-shore forms, then some lowland forms, then some upland plants and animals, and finally man. So you'll see a series as you go up I-70. Do they still have the signs? Every so often, so many 100 million years old. And so it'd be nicer if they told you about the fossils that were in there and things like that. But you get these series of layers deposited during Noah's flood, and basically the buried remains of different environments in a progressive change, not from simple to complex evolution, but from complex sea life to complex near-shore life to complex lowland life to complex upland life. And so it's a sequence of burial during a year of Noah's flood rather than a sequence of evolution over 500 plus million years. Quite a difference in interpretation. But Florida doesn't look like that. In fact, it's really hard to find a genuine rock in Florida. They must have, Indians had to do a lot of trading just to get some flint, something hard enough to make an arrowhead. And so, we're thinking of the pre-flood world as different environmental zones. Trilobites living down here, and some sharks over in here, some dinosaurs living in this kind of environment, some in another, mammoths and mastodons up here and so on. But in Florida, we've got this fossil hash. Where did that come from? Well, this seems to be post-flood fossils. We usually say most of the fossils formed during Noah's flood. There would have been a few here and there formed before the flood, and there are more formed after the flood. So there are significant post-flood catastrophes. When Noah got off the ark, the earth didn't suddenly, settle right back to the way it was before the flood. In fact, it never settled back to the way it was before the flood. And there were still regional catastrophes, of significant scope, and changes in climate that had a lot to do with survival and migration patterns and so on. And so before the flood, and even evolutionists would say before the Ice Age, the Earth had a mild climate from pole to pole. So you find alligators and palm trees fossilized near the North Pole, near the South Pole. And obviously they don't live there now. And it looked like everybody agrees the Earth once had a mild pole to pole climate like that. What happened? Well, that was replaced, by an Ice Age. But the evolutionists and creationists agree there was an Ice Age. But how did it happen, and when did it happen? And the evolutionists haven't got a clue. Because what happens? In evolution, everything has to happen very, very slowly. And so whatever theory, the sun gives off less light, volcanic action produces lots of dust, whatever mechanism they want to use, they always have the Earth cool down slowly over a long period of time. Well, if you cool the Earth down slowly over a long period of time, you don't get an ice age, you get a cold Earth. To get an ice age, you have to have seemingly impossible conditions. You have to have warm oceans next to cold continents at the same time. You need the warm oceans for lots and lots and lots of moisture to evaporate. That moisture, as it evaporates, can fall as snow and ice in the higher latitudes and altitudes. So up on the rising mountains after the flood and up near the poles, this moisture can fall as snow and ice. By the way, one part of North America that never had glaciers on it?